All right, so I have to stay home with the kid today, so you guys get a video, take some good notes. Remember to pause when you need to pause, and remember Miss Harrod is next door for any questions that you might have. She has A lunch and then teaches pre-calc B and C, so we overlap during that C chunk. And she does have honors algebra 2 during fifth hour D and E, so just be mindful of that if you head over there to talk to her. So today we're going to focus on those slant asymptotes. So we talked about those, that where it goes to 0 when the top is less than the bottom. I'm sorry, top is less than the bottom. We talked about y equals the number when the top equals the bottom. And then finally that case with the slant asymptote when the top is one bigger than the bottom. And then yesterday we practiced synthetic division so that we could come up with those slant asymptotes today. Okay, so slant asymptotes can be found using synthetic division, and they always show up as y equals mx plus b. So they look like the equation of a line, and they'll behave because this is like 1, right? Y equals m, the slope, I'm sorry, the 1 should go here. It's an odd function. So it is an odd function with either a positive leading coefficient, and that will take us to positive infinity and negative infinity, or it has a negative leading coefficient, and that'll be negative infinity and positive infinity. Okay, so when we notice that the numerator is 1 bigger degree than the denominator, we're going to use synthetic division. Okay, so this isn't the funky one that we were doing yesterday. I'm going to put a 3 in the corner, and then I'm going to list my coefficients: 3, negative 6, negative 9. Bring that down. 3 times 3 is 9. I get 3 here, 9 here, and I get 0. This is my remainder. The thing about this is that we don't really care about the remainder. So this one has no remainder, but I don't actually care about it. Okay, this is my constant and my x. So my answer is in that form, y equals mx plus b. If I drew this slant asymptote in, right, I would start at 3, and I go like up 3 over 1 or down 3 over 1, and I would have an asymptote that looks like this. And you guys could graph this on Desmos to get a actual good picture of it. It probably has another asymptote, but at the end it will hug this line here, this 3x plus 3, which means that I have a positive leading coefficient. When I head to the right, I go towards positive infinity, and when I head to the left, I head towards negative infinity. Okay, so if I graph this, save this, 3x squared minus 6x minus 9 divided by x minus 3. Okay. And I can put that over here. You will notice that this particular function goes towards positive infinity on the right and negative infinity on the left. Okay, so we can just use our graph to help us verify that. Okay, remember you can pause at any time. Let's just do another example. I'm going to use synthetic division. I'm going to put 6 in the corner. I tried to trick you on this one. This one's not in standard form, so make sure that you list your coefficients in the correct order. What do I get here? Negative 18, 17. 6 times 17 is some number I don't know, and I don't feel like using my calculator right now because, like I said earlier, the remainder doesn't matter for these. What matters, negative 17, is only Only thing that matters is this part, because all I want is that y equals mx plus b portion to see what this one looks like. So if I graphed this one, I'd start at negative 17, and then I would, do my down 3 over 1. My slant asymptote would look something like this. So I have this here. I have a negative leading coefficient, negative 3. This one goes towards negative infinity on the right and positive infinity on the left. If I graph this one, I need to pull this over here for myself here. I'm going to have x minus 3x squared plus 2 divided by x minus 6. Okay. And we can see, if I zoom out enough at least, if I plug in that line, that negative 3x minus 17, there it is. Okay, notice how at the ends, remember end behavior, as I go more and more left, 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 I get higher and higher and higher towards positive infinity. So that's as x goes towards negative infinity, I go towards positive infinity. And then as I go right, as I go towards positive infinity, I go down, down, down towards negative infinity. So graphing these really helps me see what this picture looks like in the end and match towards these. Remember I said, whatever day we wrote these down, that you could either kind of like memorize or get to know or think about the shapes of these pictures and think about, if I was walking on the x-axis, where do I go to find my y? Or you could just match to the pictures. And so if you want to match to those pictures, that's this one here. Okay, we're going to do one more example. Remember, you do not have to keep up with me. You don't even have to ask me to stop like you normally have to do. You can pause me at any time and take a little break. This last one is like we did yesterday, the really tricky ones where we have to divide something out of all of these. So this has to divide out a 2 because of my leading coefficient, and the divisor has to be 1. So when I divide out a 2, I get x plus 1/2, or you can use 0.5. And then I need to divide a 2 out of everything here. So 2x squared plus 4x plus 8. Okay, so I'm going to put negative 0.5 or negative 1/2 in my, I'm going to put negative 1/2 in the corner, and then I'm going to list my coefficients. 2 times negative 1/2 is negative 1. I get 3 when I do this. 3 times negative 1/2 is negative 1.5. I am not using a calculator. I have not had coffee yet this morning, and I was up with a sick kid, so double check my math for me. I do not care about the remainder. What I do get is y equals 2x plus 3. Okay, so I am following this chunk right here where I have a positive leading coefficient. I go towards positive infinity on the right and negative infinity on the left. Okay. Our last slide is that slide where I kind of summarize everything. Of course, I would like you to watch this slide and verbally think about these as I go through them. Okay, our case number 3 is when the numerator is greater than the denominator. We use synthetic division to give us the equation of the slant asymptote. I think I said I was going to put asymptote spelling on the test, right? Okay, if you have a positive m, then your y will equal something like, 3x plus 2, for example. Let's just say that. Remember, I don't care about the remainder. Then I go to positive infinity and negative infinity. If you have a negative m, your slant asymptote, we had one of those. It was negative 3x minus 17. And then it goes opposite, negative infinity and positive infinity. Okay, thanks for taking notes today. We will be reviewing to get ready to take a end of unit test next week.